Hello, welcome back to the Young Professionals Math Bootcamp. This is lesson number 5, ratios and proportions. First thing we're going to talk about is what is a ratio. So let's look at the first slide. A ratio compares two numbers. So it's always going to be comparing two numbers. So our first example, we have a baseball pitcher throws out 5 batters for every 2 batters he walks. So what is the ratio of strikeouts to walks? So there are the 3 examples of the way a ratio can be written. It can be written as a fraction. So in this case, it would be 5 to 2 because he struck out 5 batters and he walked 2. So that would be 5 to 2. You could also write it with a colon in the middle, so 5 colon 2. Or you could use the word 2, 5 to 2. So those are all correct. You might see it any of those ways. We're going to use the same example on this slide to answer the question a little differently. And it says, read carefully. Using the same example, answer the following question. So same example as before. What is the ratio of walks to strikeouts? So the first word mentioned in this question is walks, and then strikeouts. So you have to write it in that order. So we're using the same information. He walked 2 players, but he struck out 5. Because the word walk comes first in this question, you have to write the 2 first. So it would be 2 over 5 or 2 to 5. So you want to read carefully and make sure you're putting those numbers in the correct order. So let's look at the next slide. We have another example of a ratio. In this one, not all the information is given exactly. You might have to put some of it together yourself. So the girls' soccer team won 7 games this season. They lost 4 and tied 1 game. What is the ratio of games played to games lost? And so, of course, I have write it out. So if I were to write this out on my paper, and again, you should do the same, at least while you're practicing, you want to write out all the information that you're given. So we know that they won, the girls' soccer team, they won 7 games. They lost 4. And then they tied 1 game. Now, the question is, what is the ratio of games played to games lost? So games played to games lost. So, and I'm writing it out as a fraction. Again, you don't have to. You could write it out with a colon in between or the word to. I like to write it out as a fraction, but it's up to you. So the games lost, we know. We know that they lost 4. But how many games were played altogether, it doesn't tell us, so we just have to simply add. So 7, they won 7, lost 4, tied 1. So we know that altogether they played 12 games. So this is just an example of when you have to do an extra step. Again, it's all about reading carefully to know. And because the question was asked, games played to games lost, you have to put it in that order. Now, whether it's written as a fraction or if it's written like this, you are going to have to reduce it. Even though this isn't written as a fraction, you're still going to reduce it. So I would divide both by 4 because both numbers are divisible by 4. So I would get 3 to 1. And the reason you want to do that is because in real life, again, you want to make things as simple as possible if you're explaining them or if you're giving a report. If you're talking about numbers in the thousands or 10,000s or millions, you want to put it in the simplest form possible. So if you're talking about, voters, how many people voted for one candidate versus the other, it's easier to say for every 4 people that voted for candidate A, 2 people or 1 person voted for candidate B, as opposed to using the larger numbers. So you always want to reduce when you can. So if you were to write it as a fraction, it would look like that. If I were to write it this way, it would be 3 to 1. This would be 3 to 1. So for every 3 games they played, they lost 1. So the rest of this slide gives you that information. Okay, our next example, we're talking about proportions. So one example you'll see a lot, and you'll see it in this slide, is miles to gallons. So if a car travels 25 miles on 1 gallon, how many gallons will it need to travel 250 miles? So we're going to write that up here on the board, again, just to break it down a little bit. And again, you want to use what you already know about the problem. So for this particular car, we know that the driver can drive 25 miles on 1 gallon. But the question is asking us, this person needs to go 250 miles. How many gallons will they need? So this is a proportion. A proportion just means that you're setting up 2 equivalent fractions to find a missing number. So if we don't know how many gallons we'll need, we're going to call this x. So you can put a variable in the place of the missing number. A variable is just a letter that represents a missing number. So you could use m or n, a, b, it doesn't matter. Usually you'll see x used. So we know, we're going to put up what we're given. We know that for 1 gallon, they can drive 25 miles. But we want to know how many gallons that person will need to drive 250 miles. With this example, you can look at it a couple different ways, but I want to point out how to figure out the answer to a proportion problem, how to set it up, how to solve for the missing number. With these, you're going to cross-multiply. So cross-multiply means you're going to look at the 2 numbers diagonal and multiply them. So you would write 25 times x, and then 1 times 250. So these numbers just being in parentheses means you're simply going to multiply. When you have a variable and you're multiplying with that variable, you're just putting it right next to the number. So when you see this, it just means these 2 numbers are being multiplied. And now 1 times 250 is 250. So we're jumping into algebra a little bit here. We'll do a little more with algebra in a different lesson, but this is good to practice. And it's helpful to know this when you get to percentages. So we have 25x equals 250 because we cross-multiplied. And it doesn't matter if this was 250 and this was 25x. It would mean the same thing. So that part does not matter. You're going to come out with the same answer. So in order to find out what x is, we want to do the opposite of this current operation. Right now, remember, they're being multiplied. What's the opposite of multiplication? Division. So we're going to divide both sides by 25. Why are we going to divide both sides? Because we have an equal sign. So we're saying that these 2 numbers are equal. If we want to keep them equal, we have to do the same thing to both sides. So I'm going to divide both sides by 25, and you're going to solve for x, and you get 10. So that means that this person needs 10 gallons of gas to drive 250 miles. Now this is a simpler explanation or a simpler example because they are fractions. So technically you could simply look at this and say, okay, to get from 25 to 250, I just multiplied by 10. I'm going to do the same thing down here, and you would get 10 gallons. But it's not going to always be that obvious. You're going to have different numbers, maybe with fractions or decimals. So you want to know how to cross-multiply. So again, just think cross, you're going diagonally. You're multiplying these 2 times these 2. You want to keep in mind you only cross-multiply when you have this equal sign. Don't get it mixed up with multiplying fractions. Sometimes people will think that they're the same. They're not. So for example, if you have 25 over 1 times 250 over x, this is not when you want to use cross multiplication. This is totally different. So only when you have that equal sign, that's when you want to cross multiply. Another example on the screen, on the PowerPoint, you have another proportion you can set up. You have 3 inches equals 150 miles. How many miles are represented by 10 inches? So set up what you already know. You're already given most of the information. You know, in this case, that 3 inches equals 150 miles. So this is just an example for maybe you have a map that you're looking at, and they're telling you that 3 inches on the map equals 150 miles. Clearly, 3 inches does not actually equal 150 miles. It might be that that's on the key of a map. So they're trying to tell you that 150 miles is represented by 3 inches. We want to know if you see 10 inches on that map, how many miles is that? So again, we will show this one on the board. Another cross multiplication problem. And again, these are proportions. Again, just think proportions. You're keeping two things equal. You're just making them larger or you're making them smaller, but you're keeping them equal. It's similar to finding your equivalent fractions. So 3 inches equals 150 miles on this particular map. We want to know, well, how much is 10 inches going to be? Again, this is what we don't know. Whatever we don't know, we're going to make our variable. We have our equal sign, so now we can cross multiply. 3 times x is 3x. 150 times 10 is 1,500. Remember, when you multiply by 10, all you have to do is add a 0. So that's another trick you can use. If you're multiplying by 10, just add a 0 to this number. So that becomes 1,500. Remember, to get the x by itself, I have to divide by 3. Right now they're being multiplied. I want to do the opposite. So I want to divide both sides by 3. And x equals 500. So if If 3 inches equals 150 miles, 10 inches equals 500 miles. And again, always check your work. That's what I was doing, was double checking. It's really easy to make a mistake. This would be one, if I were taking a test, I would probably still write this out to prevent myself from making mistakes. And then if you had to, you could use a calculator, do it by hand, but just double check your work as you go. And also, like we talked about in the very first lesson about double checking your work to make sure it's reasonable and it makes sense. If we're looking at a map and you see that 3 inches represents this amount, and 10 inches is about, 3 times that, 500 makes sense. If I had added an extra 0 by accident and my answer was 5,000, I would stop and think, that doesn't make sense because this isn't that much of an increase. It shouldn't be that much bigger. So always double check your work. And here on this slide, we just have that question and process written out. So that is the end of ratios and proportions and a little bit of algebra because I threw that in there. So hopefully that was helpful, and I will see you in the next lesson.